Okay, lesson 3, the ambiguous triangle. So what is the relationship between sine 20 and sine 160? So if we go sine 20, we get 0.34. And if we do sine 160, we also get 0.34. So they are the same or equal. Cos 40 and cos 140. So cos 40 is 0.766 and cos 140 is negative 0.766. So they are the opposite. One's positive and one's negative. And tan of 50 is 1.19. Tan of 130, negative 1.19. So their relationship is opposite as well. They're plus minus. So if we were to write 3 rules, then I could say that the sine of an angle is equal to the sine of its supplementary angle. Did you notice the pattern that those two angles added up to 180, those two added to 180, and those two added to 180? Okay. Cos of an angle would equal the negative of cos of its supplementary. And tan of its angle would be negative of the tan of its supplementary. Okay. Next, we're going to talk about the SSA situation that could result in different scenarios. Okay, so a 36-degree angle, so that's right there. A is 10 centimeters and B is 9. Okay, so this is angle A right here. So side A would be across from it. So B is going to be this one. Okay, so B is 9 centimeters. So I'm going to go through that angle 9 centimeters out. Okay, and if A is 10, I'm just going to extend this line. I don't know how long this line is, by the way. I'll just fit it across my whole page. Okay, so where will 10 go? If I swing it around my pivot point, 10 would fall in place right here. So if you could see me swinging it around, where is 10 ever going to meet? It's only going to meet once. Okay, so if the opposite side is longer than the adjacent side, so that's the opposite adjacent, then there'll just be one triangle that will ever form. Okay, 36-degree angle here, same thing. And then A is across, so B is adjacent, so I'm going to go out 9 again. So it's 9 centimeters out. Just going to draw this a little darker. Okay, it says determine the height of the triangle. So the height is perpendicular, straight up and down. Okay, so I'm going to use SOHCAHTOA. So sine of 36 equals height over 9, opposite over hypotenuse. So times them. So 9 times sine 36 equals 5.29. Okay, and I want side A to be 3. So if I think about 3, 3 is this distance. Three is never going to reach that bottom line and form a triangle. So I can't make myself a triangle. So if the opposite side is shorter than the adjacent and it's also shorter than the height, or the height of the triangle, then there won't be any triangles that form. Okay, 36 degrees again. And this time I want my adjacent side to be 11. So I'm going to go all the way out to 11. Okay, so now it says to find the height of that triangle. So sine of 36 equals the height over the hypotenuse. Height over hypotenuse. So sine 36 and times 11, 6.47. Okay, so now the opposite side is 9. So where does 9 occur? So 9 occurs down here, so if I swing it around, I could form my triangle right here. Whoa. So that meets the line, but I also noticed that it meets the line over here. So I could have two different triangles. The 11, 9. So here's one triangle. 11, 9, and the third side. And the other triangle would be over here, 11, 9, and the third side. So there's my two triangles that could have formed. So writing a rule, if the opposite side is shorter than the adjacent, but at the same time longer than the height. So if the opposite side is in between, right, because 9 is in between those two values, then there's going to be two triangles formed. Okay, so a summary. Opposite side is longer than the adjacent, one triangle. If the opposite side is just smaller than the height, then you're not going to be able to reach. If the opposite side is between those two values, okay, just like this, you're going to have 2. And if the opposite side is exactly equal to the height, so if it's exactly, then you're just going to have 1, and it's going to be a right triangle, one specific right triangle. Okay, there's another. So opposite side is longer, just 1. If the opposite side is shorter, then you have to figure out. Okay. So now we're going to solve, and I'm going to use that exact triangle that we did before. So 36 degrees, 11 and 9. So I already know that there's two triangles because we've already done this one. So 9 reaches right here. Okay, so 11, 9, 36. So again, I'm going to highlight some two triangles. So I'm going to have 11, 9, and something. And then this, I'm going to have 11, 9, and something. Okay, so let's start. So 9 over sine 36 equals 11 over sine b. So we are in our calculators, so times, divide, and inverse that answer. Okay, we get 45.9 degrees. Okay, but don't forget now that we learned back here that the sine of an angle would be the same as its supplementary angle. So what's the supplementary angle to this? 134.1 degrees. So that angle B could be this or that. Okay, so angle B across from 11, you can see across from 11 is either this one or this one. So this one is the acute one, and this one is the obtuse one. Okay, now if you are a person who can't organize your thoughts, I suggest that we have a big triangle and a little triangle. So they both have a 9, and they both have an 11, and they both have a 36 degree, right? So here's my organization. So angle B in the yellow triangle, in the pink triangle. Now angle C. So angle C in the yellow would be 180 minus 36 minus 45.9. So this top angle, right, 180 minus those two is 98.1 degrees. Okay, now if I cover that up and just look at the pink triangle, 180 minus 36 and 134 leaves me with 9.9 degrees. So now I can solve for side C. So I'm going to go 11 over, 9 over sine 36. There's my matchup. 9 over sine 36 equals C over 98.1, sine of 98.1. And I'm going to multiply and divide. So I get 15.16. So that's that side. And the other option for C, so I'm going to go 9 over sine 36, my given ratio, equals C over sine 9.9. So that's in the pink triangle. So this, so I'm going to times, divide, and I get 2.63. Okay, so those are your two triangles. That is the ambiguous case.